All right, welcome class. Coming back with some exponential equations and applications. We're now going to get into ways to solve exponentials and then how they relate with solving using logarithms. So we're going to go, this is where we're going to end up with some word problems, right? This is kind of the whole idea. Why we learn mathematics is to critically think about word problems. It's not to do computation. There's software that does most of that. All right, so we're going to solve exponential equations, and then we're going to use exponential equations in applications. All right. Some exponential equations can be solved using what's called an equivalence property of exponential expressions. This is pretty straightforward. If your base is the same and you're raised to two different powers, those powers must be the same. So that's the idea. If we're saying that this is equal, and we have a base here that's equal to this, the base of something is equal to the same base of something else, then those two somethings must be equal to each other. The idea is, if I say b to the power of x is equal b to the power of y, then x must equal y. Things that have to be true. One, the base has to be greater than 0, and 2, it can't be 1, right? Because 1's kind of hokey that way. And that's only because it's our unit for everything. Let's apply some of this. So here I have 5 to the power of 3x minus 1 is equal to 125. Well, first thing, I want it to have the same base, and they don't right now. But 5 to what power? To what power would give me the 125? So 5 squared is 25, but 25 times 5 is actually 125. So this is equal to 3. This is equal to 3x minus 1. Now that the bases are the same, this is equivalent to basically the bases canceling each other out. They're filtering off. So we have 3x minus 1 is equal to 3. I'm going to add 1. So 3x is equal to 4. Divide by 3. Divide by 3. X is equal to 4/3. And then the great thing about these is you can check. A lot of algebra you can check to see if you're right. So you know if your answer is correct before you hit submit. So if I plug in, so this is my check. So 5 to the power of 3 times 4/3 minus 1 should equal 125. Well, 3 times 4/3 is 3 over 1, and the 3's filter off, so that leaves me with 5 to the power of 4 minus 1, and again it should equal, we're hoping, we're checking if it's going to equal 125. 4 minus 1 is 3, so this is 5 cubed, which does equal 125. Check. So this answer is correct. Remember, that was just the check to see if we're right. This is the correct answer. All right, let's do some more. All right, we don't have the same base, so we need to consider the bases that are appropriate here. Here I see that 1 over 4 is really the same as 2 to a negative power. So that could be written as 1 over 2 squared. And then I could do 8 as 2 to the power of 3 all to the power of x. Let's do the left side first. That could be written as 2 to the negative 2 power. And over here, power raised to a power is multiplication, so this is really 2 to the power of 3x. Now that the bases are the same, they filter off, and I'm left with negative 2 is equal to 3x. Divide by 3, divide by 3, and that filters off, so negative 2/3 is equal to x. And again, that's what I have as the answer. I can check, because I want to make sure I plug in the right answer. I get the right answer on my homework, on the quiz, the exam. So I'm going to check, is 1/4 equal to 8 to the power of negative 2/3? First, I'm going to deal with that negative. That negative is going to flip the 8. So it's going to become, let's see, maybe do that over here for a second. That's going to become 1 over 8 to the power of 2/3. So I'm going to leave it like that. And then the left side is still the 1/4. That's staying. We're questioning it. What is that really? That could be written as 1 over 8 squared, the cube root of 8 squared. So I can only pull out pairs. So let's consider what the pairs would be, and I can only pull them out once. So first, 8 squared. 8 squared is 64. And I'm going to pull out 2s, see how many 2s are in 64. So first I'm just going to go ahead and do a little factoring. 2 goes into it 32 times. 2 goes into that 16 times. 2 goes into that 8 times. 2 goes into that 4 times. And 2 goes into that 2 times. So 8 squared, which is 64, is 2 times 2 times 2 times 2 times 2 times 2. So this becomes 1/4 equal to 1 over 2 times 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5, 6. 6. And this is the cube root of that. Since it's a cube root, it means I can only pull out I can only match triples, and they only come out once. So here's a triple, it can come out, and this is another triple, and it can come out, so that would get rid of them. So then 1/4 is 1/4 the same as 1 over 2 times 2, which is equal to 1/4, and it checks. So negative 2/3 is the correct answer. And this way we're guaranteed that we have the right answer. You should probably check initially. I would probably check on homework. You do see it takes a little bit of time depending upon the problem. So I would check on homework when you have extra time that you do on homework. And then that way you get really good practice and you recognize your mistakes that you may or may not be making. And then you can quickly just go to solving like on the exams. All right, so let's... Oh yeah, here's one for you to do. So I'll let you guys do that one. Again, have some fun with it. You're probably going to use a base of 2 in both cases, so of these. And we'll move on. If you have a question, of course, come into the Math Center. ask me before or after class. Okay? All right. So let's solve some exponential equations. And reality is that most exponential equations cannot be rewritten to have matching bases. That's a nice property, and it's quick when we get it. But in the real world, we don't see nice. Nice math doesn't really happen in the real world. You guys are getting what we call textbook problems that are actually given because they're nice. The reality is that most things in real mathematics is very ugly, and what you guys do in the real world, and what you guys will do in the real world, is going to be very ugly. It's not going to come out clean and nice and exacting that we like. To solve these, we isolate the exponential expression, and we take a logarithm of both sides, and then we apply the power property of logarithms. So let's have some practice with those. Straightforward here. We can, we've isolated, this is already isolated. I don't have to do anything, so that's a win. My exponential function is over here. So what I can do is I can take a log of both sides. So I'm just going to use the natural log. That's usually what I use, just because it's less to write. So ln of 2 to the power of x is equal to ln of 7. And now, why can I do this? Genuinely, I can throw any function at an existing expression I want to. Some of them don't help me solve them, right? If I have 3x, I don't know, is equal to 9. Now, the function I'm going to throw at this is division, right? Because it's easy and it's going to give me the answer. It doesn't necessarily mean I have to. I could throw a log at both sides. That's within my prerogative. I totally could do that. And I could still end up getting the value of x. It would just be harder and a lot more work. So sometimes things are more work if we don't do the right function. In this case, because I have this power here, I want to use a log, because I know that logs have a property where I can pull this down in front. So that's why I'm choosing to use that. Just like because this is 3 times x, it's going to be easier to undo it. If I take division, I could certainly throw something weird at it, but it's not going to help me solve it. Here I'm throwing what's going to help me solve it, and this is going to give me x times ln of 2 is equal to ln of 7. And then I could, because this x is timesing the function, I can divide by this function and do the same thing over here. And now I know that x is equal to ln of 7 divided by ln of 2. And ln of 7 and ln of 2 are just nice, easy things you can plug in your calculator. Log of 7 divided by log of 2. And I actually hit the log button, but it doesn't really matter. They'll be equivalent. And I get, this is approximately, maybe I'd put it over here, approximately equal to, maybe we'll do 4 decimal places again. 2.8074. There we go. So you can attempt it, see what you get. Hopefully you're getting about the same response when you plug it into your calculator. Again, I could have used log instead of ln. log of 7 divided by log of 2 is equivalently the same thing, is the same as that. And this partially comes from the property that this didn't have a log to begin with, so I chose what I was going to throw at it, and this is the change of base formula is what's really happening. So yeah, same thing. All right, let's try a different one that's a little bit more challenging. Here, this is not in the right form for me. It is not all moved over. It is not friendly. It is all of those things. So first I need to isolate my exponential term. That's this piece. So to do that, I need to minus 4 and minus 4. That gives me 3e to the 2x. Be careful here, because the 3 is not being raised to a power. Just the e is. And this is equal to 7. Now, while they're like this, I can chuck the log at it. I can throw a log up here, and I'm going to go ahead and use the ln, the natural log. One, because it has e, which means my base is going to clear up really nicely. So I'm going to go ahead and do that. So this becomes ln of 3e to the 2x. And we can't pull that 2x down yet. We cannot, that cannot do that. It cannot go down here, because we have to deal with the separation of those first. And on this side, I have a ln of 7, right? I'll have ln of 7. All right. We learned that we can expand, and so that's what we're going to do. It's 3 times e to the 2x, so I'm going to go ahead and separate that as ln of 3 plus ln of e to the 2x is equal to ln of 7. And now I'm going to keep isolating, so I'm going to minus my ln of 3 minus ln of 3. So now I have those go away. So I have this ln of e to the 2x. Man, my writing's getting worse. This can pull out now. Well, after this. And I have ln of 7 minus ln of 3. And yes, I can combine that side if I need to. I'm just going to see what happens here. Let me take this up to over here, though. And we'll pull the 2x out front. 2x ln of e is equal to ln of 7 minus ln of 3. Well, ln of e is just 1. That's like saying e, because that's the base, to what power is going to give me e? Well, that power would be 1. So this becomes 1. So I have 1 times 2x is just 2x is equal to all of this. And I'm going to keep them separate. It doesn't really matter. Calculator doesn't care. And I would divide by 2 to get the x by itself, filters that off. So x is equal to ln of 7 minus ln of 3, all divided by 2. Let's do that just so you guys see what it is. That way, if you're having trouble plugging this in the calculator, and if you are, you should be able to plug this in the calculator. As is, you may need parentheses around this just to make it easier before you do the division. Let me get the approximation, and then I'll show you how to write that. But you guys probably, hopefully, are already thinking after the work that we've done. So let's see, parentheses ln of 7, close parenthesis, minus ln of, 3? 3, close parenthesis, close another parenthesis, divided by 2. And that gives me approximately 0.4236. All right, so that's what you guys should get. If you want to combine that, that's equivalently, and this is the top piece, right? It becomes ln, 1 ln of 7 divided by, not 2, 3, all divided by 2. Or it could be written as 1/2 ln of 7/3. Whichever way you'd like to write it. Since you're plugging it in a calculator, this is equivalent to this is equivalent to this. Right? These are all the same. There's just different ways to write it. One may be easier for you to plug in a calculator. Okay? Again, take your time, look over them, slow it down if you need to. And here's one for you to do. So again, take your time, move your pieces around, and you'll be okay. If you have a question before or after class, Math Center, please get some help if you have questions, because I want you to be successful with the homework and on the exam. All right, so we solved exponential equations. Let's use some in applications. If $20,000 is invested in an account earning 2.5% interest, compounded continuously, what we want to know is how long will it take the money to grow to 45,000? And we want to round to the nearest year. This means we know our P, right? This is our P. We know our A. This is our A. We even know our rate. What we don't know is T. T is what we don't know. That's what we're looking for. So let's see what we can do to find it. Let's plug some numbers in that we have. We have 45,000 is equal to 20,000. One more 0 times E raised to the, and again we got to convert that to a decimal, so it's 0.025 T. Now, I'm not going to bring a throw a log at this yet. My first thought is I want to simplify my numbers, and these numbers are pretty large, and I don't like large numbers. They're just too much. I'm not real good with numbers. And I know people think mathematicians, but I just don't do numbers. Is that right? That's 20. Yeah, 20,000, 20,000. Okay. So this filters off. And then, so on this side, I now have E to the 0.025 T. And on this side, those go away. And I'm left with 45 over 20, and that could be simplified. 5 goes into those, so this would become 9 over 4, right? So 5 will go into 45 9 times, and 9 will go into 20 4 times. So on this side, I have 9/4. Everything else simplifies. That's great. I'm going to use ln just because I have E, so that's probably my best choice. Plus, I can see that something's going to go away. So ln of 9/4. Whatever I do to one side, I have to do to the other. So I have ln of E to the 0.025. That's rough. T. And this piece can be pulled down in front. So ln 9/4 is equal to 0.025 t times ln of e. And we established from earlier ln of e is e to what power gives you e? Well, e to the power of 1, so that becomes 1. Well, now, this then simplifies to be ln of 9/4 equal to 0.025 t. If I want t by itself, that's what I'm looking for. I'll divide by 0.025. And I'll divide this by 0.025. This becomes 1. So t is equal to ln of 9/4 divided by 0.025 is equal to t, which is approximately, so t is approximately, does it say round to the nearest year? So we're going to round it to the nearest year. Again, I'm just pulling out the calculator. Oh wait, my battery's low. Recommend change the batteries. I guess I need to change batteries. Please work. Oh good, it's still working. ln parenthesis 9 divided by 4 close parenthesis, and then divide the answer by 0.025. And I get, we're rounding to the nearest whole number, right? Nearest year. So this is time in years. So I actually get 32 years. It's actually a little bit more, but it's not to 32.5. So rounding to the nearest whole year, 32 years. So if you're young and you have 32 years left to live, depositing $20,000 in an investment account at 2.5% interest is going to give you $45,000 in 32 years. So more than double, which is nice. You should consider that while you're young. All right, let's look at the next one. Oh, this is a try. I may work this one. Yeah, I'm going to work this one just because. I want you guys to follow along, and maybe I'll just work it to a certain point. Maybe I won't even plug it in a calculator. I'll just get it to that point and let you guys plug it in. All right. So determine how long it will take 8,000 compounded monthly at 6% to double and round to 1 decimal place. So I have my rate. I have my P. I have my A. It's doubling. So double 8,000. And I have my N. It's compounded monthly. So I know my N. So we're just going to plug everything in. Doubling 8,000 would be 16,000 is equal to 8,000 times 1 plus my rate as a decimal, 0.06. Man, that got hokey. All right, 6 divided by 12 to the power of 12t. So we want to know when, so my n is 12, t again, this is t is my unknown. That's what I'm trying to solve. And I'm going to do the same thing. I'm going to isolate that by dividing by 8,000. Divide this by 8,000. Cool thing, I know I'm doubling, so that's just going to be 2. So 2 equals, and maybe keep this in parentheses for a little bit longer, 1 plus 0.06 divided by 12, all raised to the 12t. I'm going to let you guys do the calculation, right? So I'm going to do this without summing that up, that quantity. I'm just going to go ahead and take I can take a log this time. I've been taking ln just because it's less to write, but I'll go ahead and do log. So log of 2 over on this side is equal to the log of 1 plus 0.06 over 12 raised to the 12t. And we did this because this piece can be pulled out front. So my log of 2 is equal to 12t log of all that. 1 plus 0.06 divided by 12. And it says round to 1 decimal place, and I want to caution you, because if you sum this piece up in here, and you round this to 1 decimal place, and then you do this other multiplication that's happening to it, your error is going to become farther and farther apart, and you're probably not going to get a correct answer. So don't round till the very end. That's the general rule in mathematics. If you can avoid rounding till the very end, it will benefit you. So let me rewrite what we have. We have log of 2, and it's equal to 12t log of the stuff. 1 plus 0.06 over 12. All right. So if I want t by itself, it's 12 times t times log. I divide by everything that's multiplying t. So I'm going to divide by 12 log 1 plus 0.06 over 12. And I'm going to do the same thing over here. 12 log 1 plus 0.06 over 12. All right. This filters off, and this filters off. Those become 1. So t is equal to log of 2 over 12 log 1 plus 0.06 of 12. And the great thing is the Alex calculator will make it look something like this when you plug it in, which I think is wonderful. My calculator does not make it look like that, but I can still do it. Log of 2, divided by, close the parenthesis, then divided by, and here I'm going to say open a parenthesis, 12 times log of 1 plus 0.06 divided by 12, and then, and then close that parenthesis, close the next parenthesis, so I have everything closed, and hit enter. And it said round to 1 decimal places, and I got approximately, I wasn't going to plug it in the calculator. Oh, darn. Oh, well, that's fine. So I have 11.6. So a little bit more than 11 and a half years. This is time in years, so in years. With a interest rate of 6%, you could double $8,000. So that's not bad. If you can find the 6%, you're doing great. Okay, so that was this try. So I did both. I did those. Oh, well. All right. You're going to do some on your homework. It'll be fine. And there we go. Awesome. So there's more coming. We're going to talk about logarithmic equations and applications next. But I'm going to end this one so it's not too big and then move on.